All right, guys, going to wrap up our third type of heat transfer. So we've covered so far kind of our first two methods of heat transfer. All right, number one, we had conduction, and this was direct contact. So if you have something that's hot and you touch it, or another object touches it, the heat is going to transfer from the higher temperature, the hotter item, to the lower temperature item. One thing, looking through our last couple assignments, that I wanted to point out is true, is that this isn't just true for solids. So if you have, like hot air, and you put, an ice cube inside the hot air, we are going to actually have heat because the hot air is touching the cold ice cube, will actually heat up the ice cube and potentially make it melt. So direct contact can be a solid, liquid, or a gas in contact. So doesn't have to be just solid, but you can have conduction through solids, liquids, and gases. Second type that we had convection. So that's the bulk movement of heat. And this is usually liquids and gases, just because if you have like some kind of cup and you have water in it, and then you add heat to the bottom, through a hot plate or fire or something, the water at the bottom here is going to heat up. And so then you've got the hotter section of water. And as water or fluids, so liquids and gases, as they heat up, they tend to expand. As they expand, they tend to rise. And so the fact that the hot water is physically moving up, and then the colder water would then physically be moving down, that's where you get convection, because the actual material that's hot or cold is moving. And then that's convection. So that's the bulk movement, because you're moving whatever hot object. If you had a hot potato and you threw it across the room, in a way it's convection, because the hot object is moving, but at the same time the heat's still in the potato, so we don't really think about it as much. So those are the two that we have covered so far. And then our third type, and what we're going to talk briefly about today, and I'll kind of have part one and part two here. Number three is going to be radiation. And this is heat transfer through electromagnetic waves. Electromagnetic waves. And probably the easiest kind of example of this is, we have the sun, and the sun shines, and then you've got a person on Earth. I feel warm. It's not direct contact with the sun, because that would obviously burn you up really quickly, and that would be bad. It's not convection, because there's not really air and space to actually move heat through warm materials there. You feel warm when you're outside in the sun because the light is hitting you. Light is just electromagnetic waves. So light is an example. And that sunlight carries energy. That energy can transfer to a person or to an object as heat. So if you're heating something through light, that's going to be radiation heating. Some examples of that, as I mentioned, sunlight. And then second example would be like infrared light. And that's potentially a nice one if you're using like an infrared cooker or a heat lamp. So if you have like a pet lizard or a snake and you've got a heat lamp, that's radiant heat. If you're standing to the side of a fire, radiation from the fire will warm you, even though you're not obviously in direct contact with the fire. There's obviously a lot of things going on there too, but sunlight, infrared light. And then the last one, and the one that's probably most common, which we'll talk about very briefly, is going to be microwaves. And that's going to be today's How is Mr. Baden Cooking His Egg for Lunch lesson. I'm going to use a microwave, and I'm going to talk a little bit about how that one's slightly different. So with sun or with infrared light, you're just getting direct kind of thermal energy through those waves. So IR light carries energy, makes things warmer when it hits it. Now, microwave, I'll have another video here in a minute, has our keys here and our timer there. What's actually behind all of that stuff usually in the microwave is a device called a magnetron. In the back. This is our magnetron. And what it does when you put food in the microwave, and I'll have eggs so that you get to see that this does work. Not that you don't know microwaves work, but just that it does work. It actually shoots microwaves, which is a type of infrared or a type of electromagnetic radiation. Microwaves. Get sent over. And what they do is whatever food you have inside the microwave, they actually activate the water molecules. So you've got your, hydrogen, oxygen. So like that's basically the shape of like a water molecule, H2O. Try to give you enough shade that you can see that. Hopefully that's better or worse. So when the microwaves hit it, the microwave actually has like the exact perfect wavelength that it takes this water molecule and makes those bonds vibrate. So the microwave vibrates water molecules. And we know that vibration, that motion, that kinetic energy ultimately raises the temperature through kinetic energy and then friction. Because as the water molecules are vibrating, they tend to vibrate against the other molecules in the food, they rub against each other. And just like if you are rubbing your hands together with friction, the temperature goes up and you are creating thermal energy, transforming thermal energy for other forms. So third type of heat transfer is radiation. So you take energy from a source, the sun or a magnetron, and you convert that into electromagnetic radiation, microwaves or light. When that radiation gets absorbed by a target food or by your skin if you're outside in the sun, that actually results in an increase in thermal energy. So third form of heat transfer is radiation, which is transfer of heat